Welcome to Core Questions, a podcast from BGS. My name's Rose and I work in the public engagement team.
And I'm Penny and I work in the communications team. Today, our core question is, can I put lithium salt on my chips? To help us answer this question, our guest is Rowan Hawkes. Rowan, would you like to introduce yourself?
Yeah, thanks for having me. I'm a sustainable mineral resources scientist at BGS. And basically what it means is I spend most of my time looking at the kind of environmental and social impacts of producing critical minerals that we need for clean technologies. And I have a particular focus on lithium, particularly produced from lithium brines in South America.
You mentioned critical minerals, which are a huge topic of conversation at the minute. Can you tell us what a critical mineral actually is?
Yeah, I can do my best. So basically a critical mineral, the thing is it varies depending on who's making that assessment. So for basically what you do is you look at how important that mineral is to the economy of the country that's doing the assessment, and then how vulnerable it is to the supply of it being disrupted. So in the UK, our critical mineral list will vary, example, from Europe or the United States. But it's basically the underlying theme is that it's a mineral that is usually essential to the economy, but there's a chance for supply of it will be disrupted.
Okay, so lithium is one of these.
Yeah, lithium's on pretty much all the critical mineral lists that have been published from different countries around the world. Yeah.
Okay, so why is it so important to so many countries if it's a critical mineral to so many places?
Okay, so the headline of a main answer to that is because of transport electrification. So talking about lithium-ion batteries, lithium is one of the key ingredients in that, and really what makes those batteries possible, because lithium is one of the lightest elements with the highest electro potential. So basically, it's the best element to be used in batteries. So that's one of the key things as we look to electrified transport. And that's not just electric cars; that's e-bikes, buses, trams, whatever everything else you might want to use electric batteries in. But lithium is also used in a variety of other things. So it's used in ceramics. It has uses in medicine, greases as well. It's also used in making certain types of glass. So yeah, a wide range of uses, but it is that electrification and transport that's the key one.
So you said lithium is very light. Like, is it light enough to, say, float on water?
So there's the classic experiment. I don't know if you guys grew up watching Brainiac as well, where they take that left-hand side of periodic tables, like the alkali metals, and added them to like a bath. And that, I think it was dramatized for TV. But if you take lithium, like lithium is very reactive. So getting kind of lithium in its pure form, like lithium metal, is quite hard and quite rare. So a lot of the time you won't see it. And if you do try and float it on water, you get quite an interesting reaction. It will kind of fizz and light up and bubble away. The stuff we're talking about in batteries is different compounds, and it's primarily two different types. So you have lithium carbonate and lithium hydroxide, and they're the two kind of compounds that are used in batteries. And it kind of flip-flops between them about which is sort of flavor of the month or year. So it goes through periods of where hydroxide is more popular because of the different battery chemistries versus when carbonate is more popular. So yeah, it varies between the two, but those are the main ones.
So as a geologist who studies or kind of prospects, I guess, for lithium, what are you looking for? Where we talk about lithium as an element, but it's not found, on its own in a rock. So what are we looking for when we're searching for lithium in the ground?
Well, it's a good question. It's been a long time since I've done proper geology and looked at rocks. Okay, so it varies. There's quite a lot of different sources of lithium and different deposit types we can get it from. The two main ones are what we call hard rock deposits, and that's from a mineral called spodumene.
I love the name so much. It sounds like a horrid disease.
Covered in spods. Yeah, doesn't sound great. So spodumene is the main hard rock mineral. And when we say hard rock, that's quite what you think of traditional mining, big pits in the ground or going underground, blasting it, crushing the rock up. Then the other primary source we have is the lithium brines in South America. So that's from salt flats. And this is where I do most of my work with lithium. And basically what you have is usually very high altitudes. At least 2,500 meters is the minimum or the lowest one, right up to about 3,600, getting up to 4,000 meters above sea level. And they're extremely arid, and you have waters that come in from the mountains. They kind of leach lithium out of the rocks that are in those mountains. This is the Andes. And then over time, a really long time periods for lithium in that water is concentrated by evaporation because the evaporation rate is so high because of the aridity and elevation. So, and then that brine basically is very, very salty, about 10 times saltier than seawater. And lithium in that is concentrated. So in terms of what a geologist would be looking for, it could be a whole range of things depending on what type you're looking for.
So it sounds like lithium is everywhere. So why is it a rare material?
Well, yeah, so a lot of people, when we talk about scarcity of lithium, they say, and we are forecast to have a deficit, so we might not be able to meet the demand for batteries with supply. So people always kind of get, then people can get a bit confused sometimes and think, well, like, oh, there isn't enough lithium. That's not necessarily the problem in terms of how much lithium there is in like the Earth's crust, how many deposits there are out there. The problem is more falls into, is it economic to extract? Can we get it out of the ground in a way that is environmentally and socially acceptable and is economic to do? And that's kind of the hard part, is finding the deposits and developing them in a way that's economic, is responsible, in getting that production on stream in time to keep up with the demand from electrification. That's the kind of challenge. But in terms of, there's not really going to be a point where we're looking around and going like, oh, we just, the Earth doesn't have enough lithium to meet demand. And also, as we build those batteries, they become a source in themselves through recycling and a kind of circular economy model.
So I want to clear up, when we're talking about brines, I feel like in our everyday life, the brine we're familiar with is the one in a can of tuna.
Yes.
But in geology, we talk about brines having many different types of minerals sort of dissolved in water. So like mineral rich water, essentially. That's accurate, right?
Yeah, that's a good description of the brine we're talking about in South America. And this is really kind of one of the hot topics, and it's quite debated in the lithium space. It comes down to, is that brine, how it should be classified and treated. Is it a mineral? Like, is it a mineral and should be treated like spodumene, or is it water? And I don't think, I'm not going to give an answer, but basically I look at it as a large component of water within that brine. And that water within the brine is quite an important component of the overall water balance of the solar systems. But it is incredibly salty and it cannot be used as fresh water. You can't drink it. You can't use it in agriculture.
So are there any fish in these salars?
No.
Ah.
Yeah, do they have their own ecosystem? Is there any life in them?
So yeah, these salars are, I think, quite amazing ecosystems, and people are always very surprised to hear that. So you do have kind of what we'd call the flagship species. So the flamingos are obviously there's a lot of attention on the flamingo populations. There's been a couple of studies done in looking at the impacts.
I did not know there was flamingos up there.
No, absolutely not.
Oh, yeah.
I thought flamingos were from Africa.
Well, I guess you get flamingos everywhere, but...
I've never seen a flamingo in Edinburgh.
Not even at the zoo.
But have you seen one in South America, in Bolivia?
Yeah, I've seen lots.
So there's a lot of kind of complicated ecosystem and sort of economic and social balancing going on. But I don't really get what happens when how we are extracting that lithium. Is it a case of like going in, if nothing else was taken into account, would someone just go in with a JCB and start shoveling out that salty water and sending it off for refining? Is that essentially what would happen?
Potentially. I'm not sure you're going to get very far with one JCB. That's a lot of shoveling. The reason we do it from these salars is they are a very environmentally friendly way to get the lithium. And that basically comes down to, if you think about it in terms of like the lithium atoms, they're already free. So they're already in a fluid. So they're kind of moving around. Whereas in the rock, the hard rock deposits, you need to break the rock up. You need to crush it, grind it, and then get it into a solution where those atoms are free and you're able to extract them out. And that takes a lot of energy. So the carbon footprint of producing from hard rock deposits is usually a lot higher than it is from producing from salars. So basically what you do is you build a bunch of boreholes into the salar, and you have a sort of extraction network, and then you have a monitoring network, and the monitoring network is there to see what effect your pumping is having on the salar. You then pump the lithium brine out, and what you have to notice is that brine, it isn't just sat there in isolation, kind of like stationary. It's always in flux with the rest of the solar system, and there's circulation currents, and there's geothermal currents probably a bit further down that are influencing it. So it's very complex to be pulling things out of that system. You pump it up to the surface, and like I said, these are extremely arid places with high evaporation rates. So you basically just put it into big ponds and let it evaporate and concentrate the salts. And then you'll run it through a succession of different ponds. And this process can take about a year to 18 months. So it's quite a long process.
Wow.
And you might take out different things at different times. So, in your third pond or whatever, you might take out some potassium and produce some potash from that. Or you might take out some magnesium, or you can also take out boron from these brines. So there's potential to produce more than just lithium from them. Over time, you'll get it to about a 6% concentration of lithium, so about 6%. And then they'll do a little bit more processing on the salar. And then usually what happens is then shipped off still in liquid form to a processing plant elsewhere. And then that's where we do a bit more chemical treatment and turn it into the kind of carbonate or hydroxides to then go off and be turned into batteries. And each of the salars are unique. They're kind of a spectrum. And kind of one problem we have is that a lot of our understanding comes from the Salar de Atacama in Chile. And actually, when you look at that as a salar, in terms of its kind of natural characteristics, it's quite a lot lower, it's quite a lot hotter, and the lithium is much more concentrated than a lot of the other salars. So when we kind of take, a lot of our understanding comes from there, and it might not actually translate to other salars
Right.
effectively. So that's quite a big question mark we have at the minute is, are the things we've learnt there relevant elsewhere? And they're each unique in many of their own approaches.
So, Rowan, whereabouts are we looking for these lithium brines, and kind of what's the big global picture that we're looking at here?
So for the salar brines, there's different types of lithium brines because it gets even more complicated. But the salar brines, we're looking at the area called the Lithium Triangle in South America. And that basically is an area that encompasses sort of the southwestern part of Bolivia, the northern parts of Argentina and Chile. So very famously, Uyuni, Salar de Uyuni, people will often see pictures of that as a salt flat. So kind of from there down into the northern parts of Chile and across into Argentina as well is the kind of area we're talking about. And then in terms of what's going on in terms of the big kind of global picture behind this, why is lithium being extracted from here? It basically comes down to the fact that these are some of the best deposits in the entire world. It's relatively low cost and straightforward, and has a low carbon footprint to extract the brine from these salars. And they've been doing it for a long time, is the other factor. And the other thing you have to consider is that Chile is probably one of the leading mining countries in the world. It's the world's leading producer of copper, very much a mining country. Bolivia has a really long, rich history of mining as well, slightly different commodities. And then Argentina, maybe slightly less of a rich mining history, but does have a strong mining industry as well. So they're all kind of strong mining countries, if you like. And then you kind of have to factor in as well that these deposits are some of the best in the world. So it makes sense to kind of go there first, and they're already producing. And what most countries around the world to do, no matter what they produce in terms of mining and minerals, are looking to capture more of that value chain. So they want to start building, more of those intermediate projects, more of the batteries in country, and capture more of that value, while still being, major producers of the lithium itself. And this is a global thing, it gets complicated everywhere, is trying to balance the rapid upscaling of producing lithium in batteries so that we can decarbonize versus managing kind of local impacts and making sure that they're produced in a responsible way where local people benefit, the countries themselves can benefit. And when we talk about those benefits, you also need to make sure that they're sustainable and long lasting. So a kind of classic example is in Chile. They were the world's leading producers of nitrates. And that had a massive effect economically on that kind of region, really positive. But then basically, for various reasons, the nitrate market took a downturn and they no longer were able to sell it. And it crashed and burned a little bit. And it basically meant they weren't worse off than they were before, but it was a really quite a hard landing from that. So that's something we're very conscious to kind of avoid this time round. And that's not just in Chile, it's everywhere. It's kind of how we can harness this point in time to ensure future economic and sustainable prosperity.
In terms of the amount of lithium that we need per year, for example, in terms of the salars, how much could that potentially produce? That's another big question.
It's a good question. Yeah, so this is always a bit of a moving goalpost. But basically, it's thought of a minute, but South America, the brines in South America have about 50% of all the world's lithium resources.
Wow.
And that's just from the ones that we know about.
Wait, 50 is in 50 or 15?
50%.
Wow.
Wow.
of all lithium resources, probably from a found in O'Brien to South America, give or take. I mean, these numbers vary depending on where you look, but about 50% that's a good number to go with. So yeah, that's not insignificant by a long way. In terms of being able to meet demand, lithium demand is going up all the time. I think it's estimated that we need a 32 times increase by 2030. In terms of where that lithium is going to come from, South America has potential to deliver a lot of that, especially as we start looking at new salars. So at the minute, there's only a handful that are producing commercially, and there is loads and loads of projects that are in kind of an exploration and development phase. So they're looking at salars, finding out how much is there, and kind of building the projects. So in terms of how much of it the overall demand will be able to met, it's hard to say because it's kind of moving over time. Where demand's always increasing as we electrify, but we're finding new resources, and it's kind of a balancing act between them. But yeah, South America is going to, and those solar brines are going to be absolutely key.
How is your job at BGS kind of creating a fair working environment in Bolivia? How are you working with the communities there?
Yeah, I'm part of what we call the Lithium Brines team at BGS. That's a team of 3 of us. And so that's with colleagues Andrew Hughes and Evi Petrovazzi, and they've been working on the lithium brines for about a decade now, best part of a decade. I've been working on it for about 4 years. So they've, most of the work I'm going to talk about here is led and been done by them before I joined. So credit needs to go to them. In terms of recent stuff, what we did last year when we went out to Argentina and Chile, we helped set up a bunch of workshops, and we met with researchers, government officials and regulators, and basically did a little bit of analysis about what are the challenges and what are the opportunities for South America in terms of scaling up lithium supply, so developing lithium supply, but doing that responsibly. And we created like a research roadmap. So basically looked at how can research help deliver that rapid scale up in a responsible way. And that report basically sets out the focus areas of where the international research communities can come together. We also identified some potential funding opportunities. And then when we were in Bolivia earlier this year, we were doing training courses on ESG. So, we're very lucky that we're able to work all around the world in BGS, and we're able to take quite an international perspective sometimes into this and kind of help, bring a little bit of an outside perspective and kind of show where international best practice is, while also having an understanding of Bolivia and maybe what practices could be applied there.
I've still got questions about brines,
I like what we've got brines into your head.
I'm thinking about the brines. So I'm thinking about the brines. I'm thinking about the ponds. With those ponds, at the last stage, are you the stuff that gets sent off for treatment and processing? Is that a liquid or is it a pile of loose salt? What are we looking at here?
So it's still a liquid in the ponds, but you're right. Obviously, as you said, it does concentrate through, and you have, precipitates, things that come out, but effectively almost a waste product that you then have to deal with. And you often see those sort of piled up little like white pyramids at the side of the evaporation ponds. So some things that are taken out are economic. They are a product in themselves, such as potassium salts and so forth. But sometimes, they do have precipitate waste as well that needs to be dealt with.
So is it almost like a slush? It's like in my head now, it's a slushy.
Yeah, it can look a little bit like a slushy, but it's definitely not one you'd want to drink.
Okay, well, that kind of leads us onto our core question then. Rowan, can we put lithium salt on our chips?
Theoretically, yes, you could take the products, the lithium compounds that do go into batteries are technically a kind of salt, but I definitely wouldn't recommend it. I don't think it'd be very good for you. I think it's better to stick for potassium salt.
Noted.
You say that, but if we already got the brines for the tuna and now lithium salt, I think we've made ourselves a lovely meal.
So lithium tuna coming soon to a supermarket near you.